Okay, this is the assignment that Coach Pfaff put up today, which is February 9th, and it's inelastic collisions. It's the second one he did about recoil. So I'm going to do the same thing I did before with the chart, just to keep my information organized. So we have two objects here. We have a shell and a cannon. And let's see. I'm just going to separate them differently since they start together. I'm going to leave a big blank there, and then they end apart. So we're going to have a mass and velocity of each. Their initial velocity for recoil is going to be 0. The mass of the shell is 25, and the velocity is 1200 after the cannon is fired. So after is there. It says, what is the recoil velocity of the cannon? If the mass of this was 100, and it wants to know the recoil velocity. So the formula here is m1 plus m2 times the velocity initial equals m1 v1 plus m2 v2. So you can see in the formula that they start together, and this is like the collision, and then they separate since there's two different masses at the end. So since the initial velocity is 0, that makes this whole side 0. So I'm just going to put 0 equals. Mass is 25, velocity is 1200, plus mass of 100, velocity we don't know. And so I'm going to multiply 25 times 1200 is 30,000. So 0 equals 30,000 plus 100V. I'm going to subtract the 30,000 under the 0 to make that a negative 30,000, and then 100V, and divide the 100. Okay, so you're going to take two of those zeros off of there to get 300. So the velocity is, it is a negative 300 meters per second. And that's negative. This answer should be negative, because if the shell is positive, the other one has to be negative because it's going the other way. It's recoiling. All right, number 2. So this time we have a 40 kilogram projectile. I'll put projectile, and we have a cannon. All right, so they start together. So I'm going to put V equals 0, and then they end separate. So the mass of the projectile is 40, and the mass of the cannon is 1250. It says that the projectile is fired at 1200, so the velocity after is 1200 of the projectile. What is the recoil of the cannon? All right, so same formula. 0 equals, anything times 0 is going to be 0. So 0 equals, and then the mass of the first one is 40 times 1200 plus 1250 V. So 40 times 1200 is 48,000 plus 1250 V, and that's all equal to 0. So if you subtract the 48,000 from both sides, you're going to get a negative 48,000 on this side, and that's going to equal 1250 V. Divide 1250 by both sides, and you're going to get a negative 38.4. Again, it is going to be negative. That should be a negative number up there, because if this one is positive, then this one has to be negative on recoil. All right, number 3, we have a bullet and a rifle. So I'm going to say bullet and rifle. All right, they start together. The bullet is inside the rifle, and after it's shot, we're going to have a mass and velocity for both. So the mass of the bullet is 0.0125. The mass of the rifle is 3.5. The rifle recoils at 3.9 meters per second. Okay, so I can think of that. If I shoot a bullet, I would think that the bullet is going to go positive, and this would be the negative. The recoil is the negative. So I'm going to make that a negative 3.9, and then it wants to know the velocity of the bullet. So 0 equals, the mass of the first one is 0.0125. We want to know the velocity of the bullet plus 3.5 times negative 3.9. All right, so 3.5 times negative 3.9 is negative 13.65. And then I'll bring all the other stuff down. All right, so we're adding a negative, so I'm going to add the 13.65 to both sides. So 13.65 equals 0.0125 V, and then divide 0.0125 under the 13. And that's going to be, I get 1092 meters per second. So I'm not sure if his answer is off, but I believe it is. All right, number 4, let me bump this down. Oh, that should be a 4. There we go. All right, so number 4, a 55 kilogram girl. So we have a girl who's holding a ball. All right, they both start at rest. Let's see if they start at rest, actually. Yeah, she's standing on ice. They're not moving. So she's at rest with a ball. Her mass is 55, and the mass of the ball is 8. She throws the ball away from her, so the velocity of the ball, we'll say away, is going to be negative. So negative 15. It wants to know the velocity. Oh, sorry. Let me back up. She throws the ball at negative 15. So the ball will be the velocity of 15, and we want to know her velocity. So I'm going to make the ball negative, so she should be positive. So 0 equals m1, m1v1 plus m2v2. All right, so 0 equals 55 times her velocity plus 8 times negative 15. 0 equals 55v plus 8 times negative 15 is negative 120. So I'm going to add the 120 to this side. So that's a positive 120 equals 55v, and then divide the 55 under. And we should get 2.18 meters per second. Number 5 says there's a bullet and it's embedded into a block of wood. What is the final velocity? Okay, so this one is inelastic. So we're going to use this formula. M1B1 plus M2V2 equals M1 plus M2V. So here we have a bullet and a block of wood. And we have a before and an after. So let's see. So the bullet's mass is 0.125. The wood has a mass of 3. What is the final velocity of the bullet and block? All right, so they embed into each other. So I guess what it's saying, sorry, I'm trying to read into this one. I guess they start, they've got to start apart. And I guess they're both, I'm not sure about this one because, all right, let me just work it out. Okay, so this one would be a bullet hit and embeds in a block of wood. So we don't know how fast the bullet was shot out at. But it couldn't have started at rest, so I don't know if he wants you to start that at rest. All right, I might have to check on this one. But The mass of the wood is 3, and that would be at rest, so we could put a 0 there. And then they embed into each other, so 0.125 plus plus 3v. But we are missing 2 things. So unless the bullet started from rest, which I don't think it did, but let me just, no, that won't work either. Okay, so let me make sure I'm reading this right. A 0.125 bullet hit and embeds in a 3 kilogram block of wood. What is the final velocity? Because he doesn't give us an initial velocity of the bullet, I mean, the wood can be at rest, but because we don't have that, I'm going to go ahead and say not enough info. And if somebody is seeing something I'm not, just let me know. But I don't think we can do that one. All right, number 6, a 1.5 kilogram ball of clay flying at 45 meters per second hits and sticks to a 6 kilogram block. All right, so we have clay and a block. All right, they start apart, so I'm going to put mass of both, and then they end together, so it's going to be m1 plus m2. Okay, so we should have a velocity of both of these. So the clay is 1.5 mass, and the block is a mass of 6. It says the clay is flying at 45, so that's going to be initial, and it sticks, so the block is just sitting there. That's going to be 0. So we're going to do 1.5 plus 6 and trying to solve for the final velocity of them together at the end. So this will be an inelastic, so m1v1 plus m2v2 equals m1 plus m2v. So here we go, 1.5 times 45 plus 6 times 0 equals 1.5 plus 6v. And so I'm going to do 1.5 times 45, which is 67.5, and this is going to be 0, so I'm going to cancel that out. And this will be 7.5v, and then divide the 7.5 under, and you get 9. All right, so I do think we're missing some information in number 5 to be able to solve for that.